Welcome dear student to our YouTube channel. Today we will learn the conjugate acid base concept in detail. So in the previous classes we have learned how to determine an acid as well as base, and in this class we will learn the conjugate acid base concept. So let's start. Conjugate acid and base. So which chemical is called as a conjugate acid and which chemical will be called as a conjugate base? This concept belongs to the one theory which we have already learned, that is Bronsted-Lowry theory. And according to the theory, we know any acid has the tendency to donate H plus ion. Similarly, the bases have the tendency to receive that H plus ion. So acids are H plus donor and base are H plus receiver according to that concept, that is Bronsted-Lowry concept. So in this case, what we will do? What I am telling that any acid, so if I consider it is the acid, it is an acid. For acid I am taking Ha. It is an acid. Which theory we will use here? We will use here what I have told here, that Bronsted-Lowry theory. Bronsted-Lowry theory will help us to understand. This theory will help us to understand the conjugate acid base concept in detail. So according to this concept, any acid after donating its H plus, it is the H plus part and the N minus part, after donating H plus ion or proton, after donating H plus ion or proton, the residual part is called as the conjugate base. So A minus here will be called as conjugate base. So what I have told, let's understand with example. If I will take here HCl and taking the help of HCl, in HCl what will happen? In HCl dissociates to give proton or H plus ion, and along with that it releases Cl minus ion, that is chloride ion, and in this case due to release of H plus ion, it is a acid according to Bronsted-Lowry theory, and the residual part after removal of the H plus ion will be called as here conjugate base. Conjugate means that can ligate it. We can in other way say that Cl minus is the conjugate base for HCl, and we can say acid has the tendency to donate H plus ion according to this theory, and conjugate base has the tendency to receive the H plus ion or proton to give the acid. The conjugate base receives H plus ion or proton to give the acid. So every acid has their conjugate base. Similarly, we can. So let's take the example of what I have told, NH4 plus ion. In NH4 plus ion, which is produced by this NH4 plus ion, is produced by the addition of the conjugate base I have completed, and in NH4 plus ion, how it is produced? So when NH3 receives H plus ion, the resulting compound will be called as NH4 plus ion. And in this case, what happens? Mark that in this case, the NH4 plus ion is produced due to receival of the H plus ion or proton by the NH3. So we can tell that if you will consider in that way, I can give also in this way NH3 after receival of H plus ion produces NH4 plus ion. You know it better that here dative bond gets produced, and here NH3 is called as a base, and after receival of the H plus ion or proton, it results in the formation of ammonium ion. It is the ammonium ion, ammonium ion, and due to the formation of NH4 plus ion by receival of H plus ion, it is called as the conjugate acid. It is called as conjugate acid. So what we have learned from this part? I will make a chart to make you understand in detail about that. So you should make heading comparison chart. So I will make here acids have conjugate base. Acids have conjugate base. Bases have conjugate acid. What I have told? Acids have this is the acid. Acids have conjugate base. Bases have conjugate acid. So how it is produced? How it is produced? I am writing. Conjugate bases are produced by loss of proton, that is H plus ion. So by loss of H plus ion from acid results in the formation of conjugate base. So by loss of H plus ion from acid, we get, or we can write here, we get conjugate base. Similarly, you can tell by gain of, it is here gain of hydrogen ion or H plus ion results in conjugate acid formation. So what we have understand in this class is all about the chart. So you can write here also. So it is the acid which resulted in the formation of conjugate base, and this section I am expressing with wave belongs to this section is the base. It is the base which receives the H plus ion to give the conjugate acid. Similarly, the acids loses its H plus ion, giving the conjugate base. So conjugate acid base concept is the most valuable part of the acid base concept. So you have to write it first. After that, I will give you another question. You have to answer me whether it is a conjugate acid or conjugate base. So you write it first. So if you have completed, I am just wiping this portion. So in this case, what I have told, H2O, I am only telling what will happen. You will name it whether it is a conjugate acid or conjugate base. Conjugate acid or conjugate base. In H2O, H2O receives one H plus ion, resulting in the formation of S3O plus ion. It is the hydronium ion. Hydronium ion. So name the compound or resulting compound is a conjugate acid or conjugate base. You try fast. After that, I will tell you the answer. So you know that any H plus receiver, that means gain, where gain of H plus ion occur, because 2 hydrogen present here, 3 hydrogen is coming. So gain of H plus ion occurring here. So where gain of H plus ion occur, so in that case the compound, all the H plus ion receiver results in the formation of conjugate acid. So this compound which receives the H plus ion compulsory will act as a base. Similarly, after receiving of the H plus ion, the resulting compound will be called as a conjugate acid of the base. Conjugate acid of the base, that means the base is here, that is water. So in this way you can conclude about the type of conjugate acid or base. So you have to remember that two things, all the acids have their conjugate base and the base have their conjugate acid. Don't be confused with these two concepts. So if you like the video, subscribe to our channel, share the channel with your friends. Thank you.